Hi, and welcome back to Algebra 1. Our goal for today is to continue evaluating expressions, more specifically numerical expressions, using the order of operations method. So by the time we get through this video, I will fully understand how to show one step per new line on my piece of paper following, please excuse my dear Aunt Sally, PEMDAS order of operations method to get there. And more specifically, if I happen to have a fraction where there's some math on the top, math on the bottom, how do I go about grouping everything on the top and everything on the bottom so that I do my steps along the way properly, which is one of the trickier types. So I'll go ahead and a couple of reminders from yesterday. In math, we have three basic types of math problems, what are called expressions, what are called equations, and what are called inequalities. If you were to see a symbol like this of an equal sign, that would make it an equation. We're not working with anything with equal signs right now, so all of your steps on your piece of paper should not include equal signs. You're going to make one new change per new line with expressions throughout the entire problem. If the math problem includes a greater than, a less than, a greater than or equal to, or a less than or equal to, that type of math problem is called an inequality. Again, in this case, we're not working with these. We're just working with the problems that don't have equal signs and don't have inequality signs called expressions. More specifically, within that category of expressions, there are two different types. What are called numerical expressions, with just numbers and stuff to do with those numbers. That's what we're currently working on. And what are called variable expressions, where there's at least one letter in the problem to represent a number. We haven't done anything yet with those types. So everything again today is going to look something like this. Numbers, and what do I do with those numbers? No equal signs, no inequality signs. And the way that we work with those types of problems is always following what's called order of operations. So my tool I gave you yesterday to help you remember, please excuse my dear Aunt Sally, or PEMDAS method. P for parentheses also includes your brackets, your curly braces, your square root signs, your absolute value bars. They are what are called grouping symbols, or I'm grouping, and inside or maybe underneath there's some math to do. That's what we're attacking first. So you need to work inside of those groupings first. Inside the grouping, you're only allowed to do one thing per new line, not that whole set of parentheses or whole set of brackets. I'm doing one thing inside the grouping per step, following this special order, so be careful. Once I eliminate the groupings following the rest of order of operations, I'm now working with anything that was originally outside of the groupings, working through MDOS. All right, so exponents or powers, things that have a base with an exponent next. From there, we're working through multiply and divide, but remember, we're looking for both of these, and we work from left to right through those two. And then we're looking for our add and subtract, again, L2R or left to right method. You'll never skip over subtraction to go do add. You want to work through this from left to right. So 2 more examples for today, and then you'll be on your own. All right, if you have to hit pause to get the problem copied into your note packet where we left off yesterday next to number 5, hit the pause button, all right, because we're going to start. -7 plus 5 squared plus a -3 minus 8. Now this one's a little bit special because when you ask the original first question of are there grouping symbols, you would say, yeah, there are grouping symbols. Inside this bracket, it's grouping math, right? Inside of here, there's some math to do. That makes it a grouping symbol, which makes it a letter P up here in PEMDAS for parentheses, brackets, curly braces, and so on. But remember, inside those brackets, we have to follow, please excuse my dear Aunt Sally, or PEMDAS, or order of operations. So we'd say we have an exponent inside of here, we have an add, and then we have a set of parentheses that's also grouping math, because inside there's subtraction. So inside of our grouping, we have a grouping, so I have to start there first, because inside of here, I have to follow this order and start with any other groupings first. So we have to start inside this smaller set of parentheses first. Everything else is going to come down unchanged. -7 plus our bracket, 5 squared, plus is still there. Now we're going to do our math inside. -3 minus 8 would give us a -11. Now I'm going to keep the parenthesis here. It's no longer grouping anything. It's just showing me that that's a negative that goes with the 11, and that's a plus, which is an operation. I don't have to put those there. It just helps me see the difference between what operation, what thing am I doing with my numbers, and the fact that my number is also a negative. All right, we're not done here with letter P and PEMDAS because we still have our brackets, which are also grouping math. So we're still working inside of here. We now have an exponent and an add left over inside there. I still have to think about order of operations right now. So exponents or add, the exponent part comes first. All we're doing now is the 5 to the second power, or a 5 times 5. Remember, it's not 5 times 2. So -7 plus, bring down our bracket. 5 squared would give us a new value of 25. Bring down our plus, and then we can have a -11 like that, right? But sometimes that gets confusing with the add and the negative, especially if that's a subtract and the negative. So I'm going to go ahead and put my parentheses back in there, just again to show that it's a negative number. All right, we're still not done with our grouping symbols. Inside this bracket, we have one more thing of this add. So we got to finish that next. We're going to bring down -7 plus our 25 plus -11. Remember, adding a negative is just like subtraction. So that's just like saying 25 minus 11, which would give us a 14. Now, in this order, all we've done is the letter P, because all we've really done is everything inside the grouping symbols. So now we're looking for everything else that would have been outside of the grouping symbols. So no exponents here. We're done. No multiplication there. And all that's left is an add, which would be our last step here. A -7 plus +14 will give us a +7. Good final answer. 1, 2, 3, 4 total steps to get us there. One more. I want to look at one more fraction problem because I know these are the tricky ones. When you have one big fraction where there's work to do on the top, work to do on the bottom, the first thing you have to do is group the top and the bottom. You need to create a grouping so that you attack the top and the bottom first. So I'm going to use brackets again like I did yesterday, but you can use parentheses or curly braces. All right, I'm going to put, that's my fraction bar. I'm going to do one change on the top, one change on the bottom. These brackets are going to be there until we finish everything inside the grouping, which will be multiple steps. All right, on the top, subtract, add, multiply. This multiply. We're going to do that guy first because it happens first in this special order. Inside your grouping, you have to follow order of operations. Down here, we have an add. These are side by side. That's a multiply, a divide. Out of those, multiply and divide would happen first, and we have to work from left to right. So we're going to do this multiply here and then multiply on the top. All on our next step. All right, so on the top, we have 12 minus 4 plus still. All we're changing is the 16 times 2 part, which would give us a 32. All right, close our bracket. On the bottom, all we're changing is the -8 times 3 portion of the problem. Everything else is going to come down unchanged. All right, so we have a -8. A -8 times 3. A negative times a positive is going to give us a negative here. So be careful. So plus -24, and then divide by -12 is still there. And then our bracket is still there because we haven't finished everything inside of it yet. All right, new fraction bar, new step. All right, on the top, all we have left is adding and subtracting. So we go from left to right. Do not skip this and go to that. We're working right here, left to right, straight through it. So we're doing this subtract on the top, and on the bottom we have an add and a divide. The divide happens first. So we're going to do this division. All right, so on the top, we're doing the 12 minus 4 portion, which would give us an 8. And on the bottom, we should be doing the -12. Excuse me, -24 divided by -12 to get a +2. All right, so up here we now have an 8 plus 32. Down here, we have -8 is still there. We haven't done anything with it. And a negative divided by negative is now a positive, so +2. All right, I'm going to go here. Hopefully you can keep working down. All right, one more thing to finish on the top and one more thing to finish on the bottom until we're done with our grouping symbols. Add on the top, we get a 40. Do our add on the bottom. -8 plus 2 would give us a -6. All right, all we've done is letter P because all we've done is all the math that was originally inside of our grouping. So we still need to go through the rest of PEMDAS here. So are there any exponents left here? No, they're not. Is there any multiplication or division here? Yes. A fraction represents a division problem, or you could think of it as a simplifying problem. So there's two things I could do here. I could take 40 divided by -6. If it's a decimal that terminates or repeats, I can write it that way. In this case, it is -6.6 on forever. So I can put a 6 with a bar notation. My other option is to simplify this to get -6 and 2/3. I don't care in this case which one of those two you give me. If you are typing and you have to represent 6 with a bar notation. 666 dot 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 is how you have to type it to show that you understand the 6 goes on forever. So it would look like this: -6.666 dot 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 is what I'm asking you to do for your bar notation numbers, since you can't put that little bar on top all the time. All right, I will see you guys later. Have a good day.